Alright, we're being asked to find the component form of this given vector. It's given with direct notation. We have a magnitude, our 42. This is kind of like how long or how large you would imagine this vector to be. And we have the direction angle, which is measured from the positive x-axis. So we're going to take a look real quick. Generally speaking, I apologize for that. Generally speaking, we're thinking something like this, where our 76 degrees is here, and our 42 is here. Now, traditionally speaking, we think of that as a right triangle, something like this. And so this is our theta, this is our 76 degrees. And we saw in the last video that we are going to be able to go in and take the magnitude of it, that's our 42, and multiply it by cosine of theta to go down here to find that x component. And we're going to be able to take v times sine of theta to find that y component. So this is kind of our basic layout here, which I won't draw out for every example I do in these videos, but just kind of a reminder there. What this really means then is that I can just go in and say that Vx is going to be 42 times cosine of 76 degrees. Just really nice. This is a very quaint little formula, a little easy way to go about just pulling out some information we need. 42 sine of 76 degrees will get us that vertical component. And then this is where we just really lean on the calculators to do all the work for us, which is pretty nice. Now you can see here this calculator's been reset. So I'm going to go ahead and clear that statement, and I'm going to go to my mode button. And notice here my default is on radians. And the problem I've been given degrees, and that's pretty traditional for vectors and for right triangle problems. So I'm going to switch to degree mode. And then we're going to take a look here and just see and make sure that things work out pretty well. What we're going to notice here are a couple of things that are important. I wasn't looking at the right thing. There we go. We're going to get these two different values here. And I'm seeing about 10.2 and 40.8. So 10.2 and 40.8. All right. It's always important to me to double check my answers to make sure that they feel like I've gotten them correct. There's not always a good way to plug things back in 100% to see how things go, but we have a couple of checks that we can run through here. The first one's an intuitive thing. We have a triangle where the side down here, or this angle down here, is 76 degrees. That would mean this angle up here is 14 degrees. Now, this is definitely not drawn to scale. I did not draw this to reflect what this would actually look like. But I see this 14-degree angle. I know that this is going to be, I'm going to refer to it as a tiny side because it's much smaller than my 76 degrees, which means over here we're going to have a larger side. So when I look at what I've gotten, I see my Vx is 10.2. It's about a quarter of this side. And so I go, okay, well, if this is about 10.2 and tiny, that meets what I said here. And this 40.8 being so large does meet my Vy. The other thing you can do is you can say, well, look, I know that the hypotenuse should be 42. So even though these are rounded values, we should get something really close to 42 when we plug this in. I'm just doing the Pythagorean theorem here. So I'm saying 40.8 squared plus, I should be more careful, 10.2 squared. And we're hoping to get something very close to 42, which we do. Now notice that ours is just a teeny bit bigger than 42. But that's because we rounded both of these values up just a little bit. So that tells me that I've done this correctly, that this is my x component, this is my y component. And so just make sure that when they ask for component form, that you use your angle brackets. Always list the x component first, the y component second. And for future videos, we're going to see it does matter also whether or not these are positive or negative. These both being positive works out really well because we ended up in the first quadrant up here. So our x component is positive, our y component is positive like it should be. So that's one of the final things you can do to at least make sure you're on the right track.